Hello viewers, welcome to my channel and thank you for watching the videos. In this video, question number 6C of 1995 UPSC CSE Maths Optional Paper 2A Complex Analysis Based Question. Suppose a power series sigma n is equal to 0 to infinity a n z to the power n converges at a point z0 is not equal to 0. Let z1 be such that mod z1 is less than mod z0 and z1 is not equal to 0. Show that the series converges uniformly in the disk z such that mod z less than equal to mod z1. So here we will be using comparison series and of course the concept of convergence. So here it is given in the question that the given series a to the power n, z to the power n sigma converges for z is equal to z0, which is not equal to 0. It means we can make an assumption that limit n tends to infinity a n z0 to the power n, that is converges, is equal to 0. I am repeating, limit n tends to infinity a n z0 to the power n is equal to 0. So we can make a n z0 to the power n mod is less than 1 because it is convergent, so less than 1, by choosing n large enough such that mod an is less than 1 upon mod z0 to the power n for small n is greater than n. Then we can write down that summation capital N plus 1 up to infinity mod an small z to the power small n mod is equal to summation capital N plus 1 to infinity mod an and mod z to the power small n, which is less than equal to summation capital N plus 1 to infinity mod z to the power n upon mod z0 to the power n, by using the concept which we got that mod an is less than 1 upon z0 to the power n. So this series converges for mod z less than mod z0, and so by the comparison test first series converges, the given series converges, and the given series is absolutely convergent. And same thing has been written in the slide that we have taken, that this is convergent, it is given where when z0 is not equal to 0, and it means summation, we should write summation a n z0 to the power n is equal to 0 tends to 0 when n is very large. We are taking summation of this series. Therefore, there exists m such that mod an z0 to the power n is less than 1 we can write down, or we can write down less than m. So we can say it is less than 1 for convergent. That is also correct, and m is some number we are taking for n is greater than equal to 0. Now let z be any point such that mod z is less than equal to mod z1, then sigma n is equal to r2 r plus p, or we can say when we are taking some number which is r, some number has been taken, or we can say that this is small n is, as I said, n plus 1, n is greater than capital N, and this is starting n plus 1, means from next term to infinity. This is what I said. An z to the power n is less than equal to, the limit will be here n plus 1 to infinity an zn, which we can write down in terms of finally less than equal to n plus 1 to infinity z upon z0 to the power n. We can write down separately also z to the power n upon z0 to the power n, and which is convergent. Now whatever I said can be written in this form, that we are assuming little bit different but concept idea is same. Let mod z1 upon z0, which we can take from here, that it is we are bringing z1 upon z0 is, and we are taking mod less than 1 when we are dividing, so this gives less than 1, and that can be written, that value which is less than 1 is rho, and then we have said rho is less than 1. Since n is equal to 0 to infinity an z0 to the power n, because here it says converges at a point z0. So we are putting in place of z0 is convergent. It means summation an z0 to the power n tends to 0 because it is convergent when n is tending to large. And now we are taking that suppose there exists m, we can say it m is 1, such that an z0 to the power n is less than 1 or m. This is also correct for n is greater than equal to 0. Now, and we can say n is greater than capital N, as I said in my previous version. Now let z be any point such that mod z is less than equal to z1. This is also given in the question. We are taking z, that is mod z is less than equal to z1. Then we can write n is equal to r2 r plus, because it is an infinite series. So we are taking some value of n which is r2 r plus p. In previous I said n plus capital N plus 1 to infinity. An mod Zn, which we can write down n is equal to r. In previous version I just write here what I said. Limit is from n plus 1 to infinity. But all terms we won't be taking its infinite series. So we are taking from r to r plus p. And here an z to the power n, which is limit is there. An z is equal to z0 to the power n and z upon z0 to the power n. So z0 to the power n will cancel out. It becomes an z to the power n. So we have rewritten it. And this is equal to m less than, now this is less than equal to m we have taken an z0 to the power n is less than equal to m, which we have taken from here, and limit for summation and then z upon z0 to the power, and when we have taken mod, that has been clubbed into less than equal to. So this is equal to m and limit, and z upon z0 is rho, which we have taken, so rho to the power. Since the series sigma n is equal to 0 to infinity is convergent, given epsilon greater than 0, there exists capital N such that n is equal to r to r plus p rho n is less than epsilon upon m. For all r is greater than equal to n and p is equal to 1, 2, etc., where n is independent of z. So thus, given epsilon greater than 0, there exists n independent of z such that this is less than infinity for n is greater than equal to capital N. P is 1 to 3. So series is uniformly convergent for all z with mod z is less